Welcome to Chapter 2, Frequency Distributions. The video series hosted by me, Tim Smith, on the Workbook of Quantitative Tools and Techniques in Marketing, 2nd edition. In Chapter 2, we'll begin by taking a look at frequency distributions. We'll be looking at interval and ratio data, so this is types of numerical data. In constructing a frequency distribution and in studying them, we'll need to learn some different tools. For instance, what is the size of each interval within the frequency distribution? How to construct a histogram using Excel. What is the meaning of skewness? Why is it important? Similarly, what is the meaning of kurtosis? And why is that important? After we've taken a look at frequency distributions, we'll then start to look at some of the statistics regarding frequency distributions. So while interval, histogram, skewness, and kurtosis is mostly about visualizing data, the central tendency and deviations, specifically standard deviations, are about analyzing frequency distributions. We'll get into those quickly. We'll be moving on to look at the weighted average mean of different kinds of frequency distributions, specifically interval data, where we must create weighted average means. All right, if you open up your Chapter 2 workbook, you'll find on the Spreadsheet tab, Female Shoe Size, the following set of data. What we have here is a frequency of responses for asking women the question, what's your shoe size? So here's my shoe sizes, 4 through 12 for women's shoes. Yes, I know some women have larger shoes, but they were not included in my sample. And some may even have smaller, again, not included in my sample. My response frequencies. So there's my response frequencies. And apparently 6 people didn't know the shoe size. Perhaps they're from a foreign country. First thing we're going to do is create a frequency distribution plot similar to what you see on page 23 of your workbook. To do so, we'll take the standard approach, finding an empty cell, going to insert, I'm going to insert a column chart, simple 2D. I'm going to now select, notice that once I select insert a column chart, the Chart Tools tab comes up. I'm now going to go ahead and select on the Design tab, select Data, going to add, series name, I think I'll call this Female Shoe Size. Values, that's the values I wish to plot. Those are the values I wish to plot. Okay. I've now added in the series I'm plotting. You can take a look at the plot. Notice this starts at size 1 and goes up to 10, but our shoe size started unknown and go up to 12. What did we forget to do? Collect our axis labels. So we need to go ahead and collect those. I'll edit. Hit this little red dotty thing and select the labels for the x-axis. Okay. We have a plot somewhat similar to what you see in on page 23. Again, this is just a single distribution, so we do not need to have this legend over here. So I'm going to select the legend and hit delete. We should label our axis because, 0 to 140. I don't really know what that means. Why don't we label those axes? Underneath Chart Tools, Design, then Layout, we have things like Axis Labels and Chart Title. Let's label our axis. I'll start with adding our vertical axis. That's the one that's going up and down. I particularly like to choose Rotated Title because I just think it looks pretty. So I'm going to type in, I've now inserted it. You see that it says axis title. And I'm going to type in the word frequency. And that'll be our response frequency. I could have also selected it this way. And if you'll notice, I'm actually typing into that little box itself. Mama would be an example of things I could type into that. Kind of hard to do that. That's why I tend to instead just type in the word frequency in this part of Excel, and it just appears after you've selected it. So that's my vertical axis. Let's also title my horizontal axis Axis titles, horizontal, title below axis, and I'm going to type in the word shoe size. And now my axes have been labeled. I can, if I want to, change my title. I can select it, just type in the words like, what size of shoe do you wear? Do you wear? Females. What size of shoe do you wear? Notice now it's actually showing what the question would be that was asked in the survey. I'm going to make it look really pretty by just slightly adjusting this top here so that it's all on one line, if I can. There we go. No, I can't. I'll just leave it as this form. Again, we have something of a continuous spectrum from 4 to 12. So I'm going to go ahead and scoot those things together or remove the gap, selecting the data, right-clicking, format data series, make the gap go away, close, click away, and you see what happens. It now shows continuous, a continuous flow up and down. I have a small problem in this, in that it's very hard to tell where 6 ends and 7 ends, and that's why I'll go ahead and add in the border often. Some solid line, usually the lighter color, close. And that looks quite pretty, very similar, and very informative. A person, when making graphs, one of the goals you should have is to enable the graph to be read by somebody simply by looking at the graph. Doing nothing more than looking at the graph, the person should be able to say, well, what's being measured, what was the measurement, and what are the options in the measurement? And this graph, it does that. Excellent. That's our very first frequency distribution. It's plotted in raw frequency as a raw count. You know the next thing you wanted to do is put it in percentage format. Now, to do the percentage, I need to know how many people are in the group. Well, I got 6 people in the unknown category divided by all the people in the group. And there we have it, divided by the sum of all the responses. 6 people responded unknown, and that's the sum of all the responses. When I be copying this from row to row, since I'm not changing the column, I don't have to worry about any of these column letters, but I do have to worry about those row letters. Now, the row number of the numerator can change, because that's the group, 4, 5, 12, etc. But the denominator, I want to always be taking the sum of the same thing. So I'll be putting the dollar signs in front of the row numbers for the denominator, which is where I'm taking the sum. Copy, paste, and put it in percent format. And we see about 1% of the people don't know their shoe size, about 28% say size 7, and 26% say size 8. If I now take this plot, copy, and paste the plot, I can then change what's being plotted by scooting this over, or I can go to Design, select Data, and underneath Female Shoe Size, Edit, Series Values, and say plot these instead. Okay, okay, okay. And there it is, the data, nicely plotted. This way we've analyzed, I'm going to scroll out just a little bit so you can see it all at once. In this way we've analyzed the responses for shoe size questions. Now, one of the first things you might notice is that I've left out the answers of 7.5. I've also left out the size of 8.5 or 4.5. What happened to the half sizes? Well, with this particular data set, we have interval data, unit interval data. It's 1 unit up, 4, 5, 6. It's a complete whole unit. So it's unit interval data. In other data sets, the size of our interval will not be of size 1. We might have gone by half sizes, or we might go by sizes of 3. I'll show you that in a second.